let's find the derivative of y with respect to x. Okay, so we've got this equation here, and so we're doing implicit differentiation. So we're deriving this with respect to x, and I'd say probably the trickiest part is going to be right here at first, because I've got something times something. So when I want to take the derivative of this, that's actually going to be the product rule. It's not real obvious, but that's what it's going to be. So the product rule says you can take the derivative of the first part and multiply it by the second part. And in that case, I'm taking the derivative of x with respect to x, so I don't need any y prime stuff. And then the difference or product rule says plus take the derivative of the second part times the first part. Now on this one, when I took the derivative of y, that does make a difference, because if you're taking the derivative of x with respect to x, that's like if you actually write it out over here, derivative of x with respect to x, it's like a 1, so we don't have to keep up with that. But if we're taking the derivative of y with respect to x, we need to keep up with it that way. Okay, then minus this, so we're taking the derivative of y, so this would be 1, and that's another dy dx. And then the derivative of x would just be 1. This is the derivative of x with respect to x. So again, technically we've got this guy, but it doesn't really do anything. So we only need to keep up with the dy's dx's. When did we take the derivative of y with respect to x? Okay, and if you don't like this notation, this one's the same thing. So since I guess since I wrote it like this over here, I'm gonna just be consistent now. Alright, so that's the calculus part. Now we just need to be able to manipulate our equation to solve this for y prime. So anything that doesn't have a y prime on it, I'm going to subtract over. I'm going to put this in alphabetical order here. And so this would be 1 minus 3x squared y cubed. Okay, now that all the terms on the left have a y prime, I can factor it out like a GCF. And then the purpose of that is I've got what I want times all of this stuff, so I can make it go away on the left side if I'm willing to divide it also from the right side. So in the end, our derivative of y with respect to x using implicit differentiation was 1 minus 3x squared y cubed all over a 3x cubed y squared minus 1.